Okay, so I believe we're recording now. So before I get to number 9, anybody have any questions before I get to number 9? Anything before number 9 before I get there? And I'll tell you what I'll do, y'all. I'll do it like this, where sorry guys, I haven't used Zoom in a little while, so okay. So let's try. Okay, so I'm going to get to number 9. Let's see, before I get to number 9, anybody have any questions about 2, 3, or 4? Anything about 2, 3, or 4? No, we good with these here? We're good with 2, 3, or 4? Okay, so then let me go ahead and keep scrolling. And what about, anyone have any questions about 5, 6, or 7? And again, guys, I'll definitely get to number 9. Anybody have any questions about 5, 6, or 7? Are we good with those? Okay. So then I'll tell you what, let's get to number 9, definitely. So this is one that that when we're doing, y'all, it's definitely one of those problems where we want to make sure that we're good with the problem here. So let's definitely go through number 9 and see if we can't figure it out. So okay, it says a shipment of microwave ovens contains 2 defective units. A restaurant buys 3 of these units. What's the probability of the restaurant buying at least 2 non-defective units? Okay, so let's do this. Let me get my pen going. Okay, so we have 7, and out of those 7, 2 are defective. Okay, so we have 2 defective. That means we're going to have 5 that are not defective, right? And the restaurant is going to buy 3. So we're going to buy 3 of them. Okay, so guys, I told y'all before, in doing these problems, I usually do my denominator first. So we have a total of 7, and we're going to choose 3 of them, right? We're going to buy 3 total. Okay, and it says, what's the probability of the restaurant buying at least 2 non-defective units? Okay, so at least 2 non-defective would mean that out of the 3 of them, 2 of them are not defective and 1 of them is, or all 3 that they buy are not defective. Okay, so out of the 5 that are not defective, we can choose 2 of those. And so out of the 2 that are defective, we're going to pick 1, or we could have, out of the 5 that are not defective, we could choose all 3 of those. And so out of the 2 that are defective, we're going to choose 0. Now, guys, this is how I would enter this in on my calculator, okay? So what you want to do is you want to put, I'm putting brackets here, but you could, on your calculator, instead of brackets, you could just put an extra set of parentheses right here, right? And this is how we would enter it in. And so if you guys want, I can go ahead and do that for you. I can show you how to do that. So let me stop sharing this part right here. And let me see if I can share my calculator with you guys. So let's see, here we go. So I think you guys can see the calculator now. See if I can see the calculator. Oh, it's not letting me get to it. So I don't know why, y'all, but I can't see my calculator. It's like behind this screen unless I can. This little. Sorry, guys. I'm more used to Teams than I am this from here. But anyway, I'll tell you what. I'll just stop sharing the calculator because I can't get it to work. But that's yeah. I know you guys can see the calculator. I couldn't see it. Sorry about that, guys. So anyway, let me come back to my notes, okay? But this is exactly how I would enter that in, okay? So let's see. Any other questions besides number 9 that anybody has that y'all want me to go over? So let me see if I can pull this up in the chat just to see if there's anything else here. So,
I have a question about this.
Yes, sir. Yes, ma'am. I'm sorry, I didn't hear you.
I have a question about this one.
About which one?
Number 9. It's
Number
the yes.
Uh-huh.
Where did you get the 1 from? Like that.
Okay. Okay. Yeah. So think about it this way. Remember how many we're going to buy? We're going to buy 3, right? And so these are great questions. I'm glad you're asking me. So guys, we're going to buy 3. And remember how many we have total? Oops. We have a total of 7, right? So out of those 7, 2 of them are defective, 5 are not defective, right? So I want you to think about it this way. So these numbers here, the 5 and the 2, that number adds up to 7, right? And then the 2 and the 1 are going to add up to 3 because we're trying to buy a total of 3. So when the question says, what's the probability of buying at least 2 non-defective? At least 2 non-defective means that 2 of them will not be defective and the other one will be because I have to have a total of 3, or all 3 are not defective and so we're not buying any from that defective group, right? So remember, the 2 is the defective group, right? So we're either going to get 1 defective or no defective, and we're going to get either 2 non-defective or all 3 of them are going to be non-defective, right? So that's where that 1 was coming from. Does that make sense?
Yes, it explains it a whole lot better.
Okay, good. I just want to make sure we're good. Excellent. Let's see. So let me see. I'm going to try to pull up the chat again so I can see. Here we go. So any other questions? Let me see. Any other questions? You are out of the number 11, definitely. So let's take a look at number 11 and number 13. Perfect. So guys, let me do 11 and then we'll definitely do 13. And again, if y'all have more questions, you can just put them in the chat if y'all want to. So let's take a look at number 11. So y'all, number 11 says 56% of US adults have very little confidence in newspapers. We're going to randomly select 10 adults, and then part A says, find the probability that the number of adults who have very little confidence in newspapers. Part A says exactly 5. Okay, so guys, this right here is one of those binomial probability problems. Okay, so in this case, my N is the number 10 because we have 10 adults, right? My P in this case is the probability that those people have little confidence in newspapers is a 0.56 because it's 56%. And we're trying to find that the number of adults who have very little confidence in newspapers is exactly 5. So here, my X is going to be 5. So I want you to notice how they're writing this here. They're saying, let's find P of 5. So guys, what I'm going to do here is I'm going to use my binomial PDF. Okay. And when we do the binomial PDF, I'm going to check something real quick, y'all, on my calculator app, because I want to make sure that I'm telling you the right way. And it's probably been just as long for you guys as it's been for me since I've done binomial PDF a few weeks back. And let's see, here we go. Yes. Okay, so binomial PDF, y'all, we're going to have three numbers. We're going to have n, we're going to have p, and we're going to have x. Okay. So we're going to go binomial PDF. PDF. And n in this case we said was 10. P was a 0.56 and x was 5. So guys, the way I'm going to get to this part right here is on my calculator, I'm going to go second and then bars, and I'm going to scroll down until I see that binomial PDF. Okay. So you know what? Let me try one more thing, guys. Let me see if I can do this again with sharing my screen one more time, or sharing my calculator. Okay. So let's try this. Go here. I'm going to share that. Okay, so I think you guys can see this. Okay, so I'm clearing this out now. And so I'm going to go second and bars. I'm going to scroll down until I see binomial PDF. This one right here, y'all. And remember, we said we're going to put three numbers. We're going to put n, p, and x. So my n was 10, comma. My p was a 0.56, comma, and my x was a 5. And so the number that I'm coming up with here is 0.2288. And I think the directions say something like we're going to round it to 3 decimal places. So I'm going to put 0.229, okay? So let me stop sharing that, and I'll come back one more time and share my notes. So right here, y'all, I'm going to put 0.229. Now, guys, I'm actually going to skip to part C, and then I'll come back and I'll do part B in a minute, okay? So part C says we want to have the probability being less than 4. So I want you to think about what less than 4 means, okay? So I'm going to kind of move this over to the side a little bit. Okay. So part C says probability that it's less than 4. Less than 4 is the same thing as saying less than or equal to 3. And less than or equal to 3 means we want to find the probability of it being 0 or 1 or 2 or 3, okay? And so if we want to find these 4 values, we could do what we just did before, and we would just do it with 0, with 1, with 2, with 3, right? We could do that and take each of those numbers and then just kind of add them up, right? But there is another feature on our calculator called the binomial CDF, okay? And what the C stands for is cumulative, meaning it's going to add them all up. And we're still going to have N, and we're still going to have P, and we're still going to have X. And our N is still going to be 10, and my P is still going to be 53, I think is what it was, right? 56, sorry. 56. Okay, and my X now is going to be the last value that we started off with, okay? And so, guys, let me stop sharing this part here, and I'm going to share my calculator with you guys again. And okay, so what I'm going to do here, I'm just going to clear this out. I'm going to go second bars, and I'm going to scroll down until I hit binomial CDF, this one. Okay, and I'm going to enter in 10, comma 0.56, comma 3. And again, what this is doing, y'all, this is finding it for 0, for 1, for 2, for 3, and it's adding them all up for me, okay? And so when I do that, I'm coming up with 0.09, if I'm going to round to 3 decimal places, 0.091. So let me stop sharing this one. And let's share our notes again. And so we came up with 0.091. Okay. And so I would come back over here and I would type in 0.091. Okay. Now I want you to look at, we're going to go ahead and do part B next. So part B says, what's the probability that it is at least 6? So notice how they write it here. At least 6 means actually 6 or more. Okay, so like if I said I want to have at least 6 kids, means I want to have 6 kids or 7 kids or 8 kids or 9 kids or whatever, but I don't want to have less than 6. Okay. So let's take a look here. So if we're looking for the probability that X is greater than or equal to 6, what this means is we can find it for 6 or 7 or 8 or 9 or for 10, and we would stop there because we only surveyed 10 adults, right? So if I wanted to find this value here, there's a way we could do that. Guys, if you remember that if I take the probability of 0 plus the probability of 1, and I keep going all the way until I get to 10, my answer should be equal to 1, right? If I add up all the probabilities from 0 to 10, 10 in this case because we were surveying 10 adults, right? The answer should be equal to 1. So if I wanted to find this amount right here, what we could do is we could say, well, let's take 1 minus, and we add up from 0 all the way to 5, right? And so the way I can find this part right here is the same way that we did it over here earlier, right? So I can go 1 minus my binomial CDF, where my N is still 10, my P is still 56, and my X now is going to be equal to 5 because it's the last value there, right? So look, we're going to do this part right here in the calculator, and I'm going to enter this in, guys, exactly as I wrote it right here, okay? So let me stop sharing that, and let me pull up the calculator one more time. Okay. And so I told you the way I was going to enter this in, I was going to go 1 minus second bars, and we're going to scroll down to binomial CDF, and we had 10, comma, 0.56, comma, 5, and let's see, enter that in, and I'm coming up with 0.530, okay? So 0.530 is going to be my answer. Well, so 0.530. So when I come back over, oops, right over here, I'm going to type in 0.530. Okay. Yes, Perla, you have a question for me? I see your hands up. I'm sorry.
Yes, sir. Just a question. How come we did not use Binomial PDF? We use
excellent question. So guys,
PDF.
I'm glad Perla asked this question. The PDF, excellent question. The PDF is when I want to know for a specific value. So like when we did part A, it said for exactly 5. So if it tells me for exactly 2 people, exactly 8 people, exactly 1 person, I'm going to use the PDF. But when I'm going to do it for a bunch of values, I could do that, right? Like, so when we did this part right here, remember when we did part C and it said, what was the probability that it was less than or equal to 3? What less than or equal to 3 meant was we were going to find it for 0, we're going to find it for 1, for 2, and for 3. So we could have done binomial PDF, and we could have plugged in the X number right here being 0, okay? And then whatever number we got, we would write that down. And then we would do it again, but now plug in the X number being 1, and whatever number we got, we would write that down. And we would do it for 2 and for 3, and then we would take each of those 4 values that we got, we would add them together, and this would be the answer that we would get. So what the CDF allows me to do is the CDF says when you have something starting from 0 ending to a particular number, you can use the CDF and it will automatically take all those three values, or four values in this case, and it'll add them all up for us. Does that make more sense?
Yes, thank you.
Okay, sure. So let me see. I want to see if we have any other questions in the chat. I know we do. Oh my goodness, here we go. Let's see. Okay, yeah, so that was number 11. We have 13 and we have 16. Definitely. So let's come back over here and let's do number 13 and then we'll do number 16. Okay, perfect. So guys, for number 13, it says, find the area of the shaded region under the standard normal curve. Okay, so I want you to notice what we're finding here on 13. We're looking for the area to the right, okay? We're looking for the area over here when we have this particular z-value, okay? So guys, in general, when we have our normal curve that looks like this, right? Something like this. Remember, the total area here, so the total area is always equal to 1. Oops, it's always equal to 1, okay? So we're trying to find this little piece right here. But whether I use my table, y'all, or whether I use my calculator, either one will always tell me the area, not to the right, but it'll always tell me the area to the left, okay? So I'm gonna show you two ways of doing this. If we wanted to use our table, right? If we wanted to use the table here, first thing we're gonna do is we're gonna find when z is equal to 1.57. Okay, so let's see if we can find that. Here's 1.5, here's 0.07. So 1.57 would be this number right here, 0.9418. So that would tell me that this area here in the red is 0.9418. Okay. Now remember what we're looking for. We're actually looking for the area over here, but we know that the total area is equal to 1. So we can just say, what's 1 minus 0.9418? And I'm just going to do this on my calculator real quick, y'all. So let me get just using my plain Jane calculator here on my phone. 1 minus 0.9418. And that would give me 0.0582, right? So this is how I could do it using my table. Now, if I don't want to use a table and I want to use my calculator. So in my calculator, y'all, what I'm going to look for is the normal CDF, okay? In the normal CDF, we're going to have two numbers. One of them is going to be our lower bound, and the other one is going to be our upper bound. Okay? So I want you to look at the picture that we had here. Here was our picture. We're going to start from this value right here, and we're going to go to the right kind of forever and ever and ever. So my lower number is a 1.57. And remember, if I go to the right forever, I'm eventually approaching infinity. So what we would use on our calculators, we would use something like 9999, right? And so guys, on your calculator, we're going to go second in bars, right? And so I'm going to do that on my calculator. And guys, I'm just going to do it on my calculator app. So let's see. Normal CDF, it should be the second one. My lower number we said is a 1.57, comma, my upper number was a 9999. And when I hit enter, if you notice, we came up with that already. I guess I erased it, but it was a 0.0582, right? 0.0582. And we got it, okay? So I hope that helps for number 13. Let's see. So let's scroll down to number 16. That was the next one we had. So what number is this? So, right, okay, 16 is right here. All right, perfect. Okay. So number 16 says, use the normal distribution of SAT critical reading scores for which the mean is 514 and the standard deviation is 114. Assume the variable X is normally distributed. And it says, okay, so let's take a look. What percent of SAT verbal scores are less than 675? Okay, so guys, what we're trying to do here in doing this problem, pen working again, okay. Part A says, what's the probability that X is smaller than 675? So what we want to do, because it's asking me to use a normal distribution, we're going to convert our X value to a Z-square, okay? So the way we do that is we're going to use this formula right here, X minus mu all over sigma, okay? My X number in this case, y'all, is 675. So I'm going to write 675 minus, the mean in this case is my 514, all divided by my standard deviation, which is 114, okay? So guys, when you're doing this part on your calculator, make sure you do put that part in parentheses. So let me do that real quick here. Okay, so I'm going to go on my calculator, 675 minus 514 in parentheses divided by 114. And I'm going to change it to a decimal. And to 2 decimal places, y'all, I'm coming up with 1.41. So the value that I came up here was 1.41. So what we're going to do now, instead of us saying, what's the probability that X is smaller than 675, we're really going to say, what's the probability that Z is smaller than 1.41, okay? And again, think about this in regards to the picture, like the problem that we just did right now, okay? So if here is 0, 1.41 might be right here, okay? And because it says less than, that means that I'm looking for the area to the left, okay? So guys, again, 2 ways we can do this. We can go back and use the table, or we can use our calculator, right? So to let you know, if I was going to use my calculator, I would go normal CDF, okay? Now remember, we have 2 numbers, the lower number and the upper number. So the lower number, if I'm all the way over here to my left, I'm approaching negative infinity. So here, what I might put in is negative 9999. And then where are we stopping at? Right at 1.41. So I'm going to do that on my calculator here. I'm going to go second bars. I'm going to go normal CDF. I'm going to type in negative 9999, comma, 1.41. Okay. And the number that I'm coming up with, y'all, is 0.9207. Okay. So for part A, I came up with 0.9207. So for part A, since it's asking me for a percent, I'm going to go 92.07%. Okay. That's how I would answer part A. Now, to answer part B, it says, if we have 1,000 SAT verbal scores are randomly selected, how many of them would be greater than 575? Okay, so we're going to do this process again, except now instead of using X being 675, we're going to use X being 575. Okay, so look, let's do that here. So the question is saying, what's the probability that X is greater than, it says greater than 575, okay? 575. So first thing we're going to do, we're going to convert this to a Z-score. So 575 minus, we said our mu was 514 and our sigma was 114. And so now what I'm going to go ahead and do is do that part on my calculator. So I'm going to go 575 minus 514 divided by 114. And I'm going to convert that to a decimal. So guys, to 2 decimal places, I'm coming up with a 0.54. Okay. And so again, since we were looking for the probability that X was greater than 575, what we're doing now is we're saying, what's the probability that Z is greater than 0.54? Again, in terms of a picture, y'all, here's my normal curve, right? Here's 0, say here's 1. So 0.54 would be somewhere right about here. And if it says greater than, that means I'm actually interested in the area to the right, okay? So again, I would go with my normal CDF. Remember, we have two numbers. We have our lower number and our upper number, right? Okay, so my lower number is a 0.54, and my upper number, since I'm going all the way to the right, would be a positive 9999. So let me do that. Second bars, normal CDF, 0.54, comma, a whole bunch of nines. Okay, and to 4 decimal places, y'all, the number that I'm coming up with is 0.2946. Okay, so we came up with 0.2946, right? Okay, now, when I'm reading part B of my question here, okay, part B says, if we had 1,000 SAT verbal scores, how many would be greater than 975? So what I would do is I would take 1,000 times 0.2946. Okay. So I'm going to multiply that number by 1,000. And it's telling me to round to the nearest whole number. So I'm coming up with like 294.5 or 0.6 actually. And so if I'm going to round to the nearest whole number, I would say 295. Okay. Let's see. So guys, as we're going through these problems, let me ask you a question. Did number 13 and number 16, are those making sense as we're going through them? Are they seeming somewhat familiar? At least the process and how we're doing them? Yeah, we're good, Kelly, we're good, excellent, good, good, good. Excellent, good, Perla, I'm glad it's coming out. All right, so guys, I'll tell you what, let me do something like this. And I know I wrote a little bit on 17, but let me ask you all a question. Does anybody have any questions about like 17 or 18 or 19? Anybody have any questions on those? Or 20, I'm sorry, 17, 18, 19, 20? 25, okay, yeah, let's get to 25. So let me scroll down a little further. Okay, let's take a look here, 25, okay. So, okay, so for 25, it says, in a survey of 2,115 adults in a recent year, 1,309 say they have made a New Year's resolution. It says, construct 90% and 95% confidence intervals for the population proportion and interpret the results and compare the widths of the confidence intervals. Okay, so guys, give me one quick second. I'm going to pull something up here on my iPad because I want to make sure I'm telling you guys, I want to use the correct notation in the correct format, okay? So just un momento, por favor. And here we go. Okay. So let's take a look here. So what we want to do, y'all, is we're going to find a couple of things. So first thing we're going to find is X, oops, not X bar, just X. And we're going to find N, and then we're going to find our P hat, okay? So my N is how many adults we surveyed. So we surveyed 2,115 adults, and X is the number that say they made a New Year's resolution. So that number is going to be 1309. And then my P hat, y'all, is going to be 1309 over the 2115. Okay. So I'm going to go ahead and do this part right here. And let's see. Make sure that we got this part. Let me get my calculator. And I'm going to take 1309 and divide it by 2115. And as a decimal, I'm coming up with 0.62. I'm going to round to 2 decimal places right now, so 0.62. Okay, so first thing we're going to do, we're going to find a 90% confidence interval and a 95% confidence interval, okay? And so I can find it here. Here we go. Well, I'm trying to find a certain thing on my calculator here. Yeah. Okay. So guys, on my calculator, and I'm gonna show you how you can do this both on your calculator and your calculator app. Okay. So what I'm gonna do here, I'm gonna stop sharing this part. Okay. And I'm gonna share my calculator with you guys one more time. Here we go. Okay, so let me turn this thing on and clear my screen. So guys, I'm gonna go to stat. I'm gonna scroll over to tests. And the one that I'm looking for is, let's scroll down a little bit. Here we go. The one proportion Z interval. Okay, so I'm gonna hit enter here. So my X, remember what my X number was? My X number was 1309. So I'm gonna type in 1309. And then my N number was a 2115. Okay. And our confidence level, the first time we're doing this is for 90%. So instead of putting 0.95, I'm going to put 0.90. And I'm going to go ahead and go to calculate. I'm going to hit enter. Oh, something isn't right. Let me see. Stat, test. Go back down. That's right. 2115. There we go. Okay. Okay, so we got it here, y'all. And so I want you to notice here, look at the little p hat. It's 0.6189. I rounded it to 0.62, right? But the interval that we're looking at is the 0.60154 to the 0.63628, okay? And it's telling me to round it to 3 decimal places on my actual problem here. So I'm just gonna write this down in my notes and I'll come back, show you what I'm doing. So 0.602 to 0.636, okay? And it told me to do it twice. And the second time it said, we're gonna do the same process for 95% confidence interval. So I'm gonna go to stat, I'm gonna scroll back to tests, I'm gonna scroll back down until I find my one proportion Z interval, okay? And the only thing I'm gonna do here, y'all, is change that 0.9 to a 0.95, okay? And I'm gonna go ahead and go calculate. And so the numbers that I'm coming up with now to 3 decimal places, 0.598 and 0.640. 0.598, 0.640. Okay. And so now I can stop sharing this part and we'll come back to our notes. So, okay, so I wrote those numbers in right here. Okay. And it says, with a given confidence, it can be said that the population proportion, we're always thinking about population proportion, y'all, okay, of adults who say they made a New Year's resolution is between the endpoints. Okay, it's always going to be between the endpoints right here. And then there is a second part to the question, and it says, let's see. Oh, I guess that's it. I was usually it asks to compare the widths. Here it is. Compare the widths of the confidence intervals. So no, the bigger the confidence interval is, this one here is always going to be wider than that. So the bigger the percentage, that will be the wider one. So in this case, the 95% is going to be wider. And if you look at the numbers that we have here, right? So if I think about drawing this on a number line, okay, and suppose I wanted to put these two numbers on. So I might label this one 0.602, and I might label this one 0.636, okay? Now I'm going to do these in red. 0.598. 0.598 would be further to the left, and 0.640 would be further to the right. So the red one is wider than, say, this one here in the green, you know? And so the bigger the percentage, that's going to be the wider one. Okay. All right. So guys, you can see some of these problems really are calculator types of problems where you're looking for, you know, those things. Okay, so would we use the next formula for the next one as well? Let's see, for number 26. Let me double check. Yes, 26, you would definitely do the same thing. You would definitely do the same thing, okay? And so guys, anytime so I want to point something out here. Anytime you're doing problems like this, like confidence intervals, and I know it can get tricky because we tend to use, you know, these features on our calculators quite a bit, right? So like I'm going to pull up, let's see. Okay, I'm going to look at, like, say, some of these here. I was trying to see if I can find another problem that was kind of similar. But, you know, this one here might be a little more similar. But anytime it's dealing with confidence intervals, right? So let's see. This is also confidence interval. But anytime it's asking you for confidence interval, let me show you the way I would do this. If you're trying to figure out, like, you know, which kind of feature should I use, right? So when I clear my calculator and I go to stat and I go to tests, anything that says interval. So here's Z interval, right? T interval. I didn't have you guys do the 2 sample Z interval or 2 sample T interval. And here's the 1 proportion Z interval, right? Those are the ones that you're going to use anytime it's dealing with confidence intervals. Those are going to be the ones that you guys are going to end up using, okay? Anytime it deals with confidence intervals. So I hope that gives you some, you know, some reassurance there, okay? Let's see. Any other questions anybody has? We just did 20. Oh, somebody has 27? Or did we need to do 27? Okay, so let's do 27. So 27, guys, I'm going to do it exactly the same way, okay? So 27 says, in a survey of 3,029 adults, 1,041 say they've started paying their bills online in the last year, and we're going to construct a 99% confidence interval. So guys, let's do it this way. I'm going to show you all how to do this on the calculator. We'll do it exactly the same way we did the other one. So remember, my N in this case is 3,029, and my X in this case is the 1451, and our confidence level is a 0.99, right? And so if I show you all this on the calculator, and again, we'll go about it the same way. Here we go. Okay, so we're going to go down. Let me just clear again. Stat, test. We're going to look for that 1 proportion Z interval. Here we go. 1 proportion Z interval. Okay, so remember what we said our N was in this case. My N was the 3029. Okay, and my X, oops, that was the wrong one. Sorry, this is the 3029. And my X was the 1451. Okay, and my confidence level was a 0.99. Okay, and then we can go ahead and go to calculate and enter. And so I'm coming up with, and I think my directions are still asking me to go to 3 decimal places. So I'm going to write 0.456 and 0.503. So 0.456, 0.503. So let me share my screen with you guys again so you can see what I'm doing. Excuse me. Okay, so right here. And guys, remember, we're always talking about, and it'll tell you right here also in the problem, we're always referring to our population proportion, right? So when I look at my choices A, B, and C, right? The difference between A and C are the word sample and the words population. And so I'm always referring to my population proportion, okay? Good, good, good. Let's see. Let me see. I want to see if anybody has any other questions. Oh, chat box. There we go. Okay, so any other questions, y'all? Out of anything here, 28 or 29, or I'm trying to remember exactly how many questions I have on the review. I think it's 29, definitely. I think we stop at 30. We stop at 33, maybe. Yeah. Okay, so yeah, let's definitely do 29. So let me scroll back over here to number 29. Okay, definitely. Okay, so it says a company that makes cola drinks states that the mean caffeine per content or caffeine content per 12 ounce bottle of cola is 40 milligrams. Okay, so I'm going to stop right there. When I read this problem right here, the mean is 40 milligrams. So the mean is equal to 40 milligrams. This here, y'all, is our claim, okay? And because this one has the equal to, that's going to be our HO, that's going to be our null hypothesis, that's going to be our HO. So the HA is going to say it's not equal to 40 milligrams, okay? So now what we're going to do is we're going to say, okay, identify the HO and the HA and choose the correct answer below. So guys, what I'm doing here is I'm looking what I wrote right here, and I want to compare it to my choices A, B, C, D, E, or F. Anybody know which one it would be? A, B, C, D, E, or F? Anybody want to throw an answer in the chat box if you know which one it is? So for what we wrote there, B. There you go. Good. Perfect, guys. You guys got it. Remember, I could have, you guys, if we were not in a pandemic, I would have said I could have stayed home today, but I'm at home, right? Okay, now we're going to do part B. It says, find the critical values and state which is, say the correct choice and fill in our answer in our answer box. Okay, so now that we've gotten to this stage, y'all, we need to figure out, is this a left tail, right tail, or a two-tail test? So I'm going to draw my normal curve. And the way we determine that is we always look at the HA, okay? When the HA is not equal to, this is telling me that we're going to have a two-tailed test. And so when I'm reading my problem here, and it tells me that alpha is 0.09, what we need to do is we need to find alpha divided by 2. So I'm just going to take my calculator real quick, 2509. Let me see. And I'm going to type in 0.09, and I'm going to divide it by 2, and I'm coming up with 0.045. So 0.045. That's going to be the area over here, and that's going to be the area over here, okay? So we're looking for two critical values, okay? So we want to find what those values are going to be. So let me see. When I read in the problem, it says we have a random sample of 30. So my N in this case is 30, 12-ounce bottles And the mean caffeine content, so my X bar in this case is a 38.3, okay, 38.3. And it says, assume the population normally is normally distributed with a population standard deviation of 7.5. So they're telling me that my sigma is a 7.5. Okay, so guys, what we're going to find out, we're going to find those critical values. One of them is going to be negative. The other one's going to be positive. So the way we're going to do this is we're going to go second bars, and we're going to go inverse norm of that number right there, 0.045. Okay, so I'm just doing this on my calculator here. Second bars, inverse norm, 0.045. And the number that I'm coming up with, if I round to 2 decimal places, negative 1.70. Okay, so this number here is a negative 1.70. So this one here is going to be a positive 1.7. So when I'm doing this on my on my lab, I would select choice A, and because it already has a plus and minus, I just need to put 1.70. Okay. All right, so I want to remind you all of something. This here are my rejection regions, and this one here in the middle is my fail to reject region. Okay, so now what we're going to do, if you look at what I kind of have drawn right here, doesn't that look like choice A? That looks a whole lot like choice A right there, right? All right, now for part C, we're going to find our standardized test statistic. So the way we're going to do this is we're going to go X bar minus mu over sigma divided by the square root of n. Okay. And I think we have those values a little bit up here. Here we go. So remember, my X bar in this case was a 38.3. So I'm going to write 38.3 minus our mu was 40 over sigma, which was 7.5, divided by the square root of n, which is 30. Okay. So guys, I'm going to do this step on my calculator as well. So I'm typing it in exactly as I wrote it with parentheses and everything. So 38.3 minus 40 divided by parentheses 7.5 divided by the square root of 30. Close my parentheses, hit enter. And the number that I'm coming up with is a negative 1.24. So I'm coming up with a negative 1.24. And so that's going to be the number that I'm going to write here. Negative 1.24. Okay. All right. So now that we found that value, then we get to choose for part D. And it says, did we fall in the rejection zone? So guys, remember right here in the middle, this is 0. The number we came up with was negative 1.24. So negative 1.24 would be somewhere between 0 and negative 1.78. So we fell in the fail to reject region, right? So we're going to say, since Z is not in the rejection region, we're going to fail to reject the null hypothesis, right? Okay, so guys, I'm going to pull up one more file that I want to share with you guys. And I'm going to be honest, I don't remember right now off the top of my head if I sent it to you guys in the last message, but if I didn't, I'm going to resend that message tomorrow, letting you guys know what you can use for the final. I just want to see if I can find it. Here we go. Okay, so now that we're here, right, we know we're failing to reject the null hypothesis, right? So what I'm going to do, y'all, is remember what my claim was. My claim up here, my claim was the null, right? So let me stop sharing this one because I want to share one more with you guys. Here we go. Okay, so this is the one I want to share with you all. Okay, so let's see if we can do this. Here we go. And this is kind of what we're looking at, this little piece of info right here. Okay, the claim was the null, and we failed to reject it. So we're going to say there is not enough evidence to reject the claim, right? There's not enough evidence to reject the claim. So let me stop sharing this, and let me come back and share my notes one more time. Here we go. So if you look, I think, here we go. So guys, right here where I have the little, number 1, I would choose from here. And we said there is not. So I'm just going to write it here. Is not enough evidence to reject the claim that the mean coffee content per 12 ounce is equal to 40 milligrams, right? Because that was a number that they had given us. So let me ask you all a question. As we went through that problem right there, so I can pull up the chat. Okay, what formula did I use for part B? I'm sorry, I just saw your message right now for part B. So let me double check. What was part B? Oh, right here, the critical value, the 1.70. Okay, so the way I found this number right here was because this was a two-tailed test. If we have a two-tailed test, whatever my alpha is, I have to divide it by 2, right? And that's the number that was the area under the curve over here, and that was the area under the curve to the right. So the way I do that part is I'm going to go second in vars, and I'm going to go inverse norm, and then 0.045. And when we did that, I came up with a negative 1.70, but because this was a two-tailed test, that's why I put it in right here, because we came up with both positive and negative. Okay. I hope I answered your question. I hope I answered your question, Jasmine. So guys, as we went through the problem, right, as we were able to go through each of the parts, and I know these problems, guys, I think I told you all that for your final, you only have 14 questions, right? You can see why there's only 14 questions, because like question 29, I mean, it takes us 5, 6, 7, 8 minutes to do the one problem, right? So guys, one thing I really want to emphasize is as you're taking y'all's final, and guys, because I have 2 stats classes, just double check, and I'll resend it again tomorrow, but double check your announcement on when your final is. So I know one of, my regular stats class, V01, y'all are testing Monday at 10 a.m. and Tuesday at 6:30, and my stats co-rec V07, believe I have you guys on Monday at 6:30 and on Tuesday at 10 a.m. Okay, but just double check to make sure that when you have your times, and I'll have those Microsoft Teams links set up for y'all as well. But you can see, anyway, my point is, you can see these problems take time to do. As I'm going through the question, I'm really, really, really trying my best to do each step slowly and carefully. And excuse me, I'm gonna stop sharing this part right here, y'all, because I want to share one more time. I think I put it in the formula sheet, but if I didn't, I will resend it. This part right here to me is like extremely helpful. Having this piece of information right here and knowing what do I need to do when I know the claim, which is the claim and which is the null, and when I fail to reject or reject. This part right here to me is just like super helpful, right? Because I can go straight to it and I can say, okay, what am I supposed to do? I'm going to pick one of those 4, right? So I'll double check on the formula sheet, but if it's not there, it will be there. Okay, I'll make sure that you guys have that as well. So let me come back and put my notes back up one more time for you guys. Here we go. Okay, guys, any other questions that you guys might have that y'all want to ask me about? And I'm hoping that 29 made sense. I'm hoping it did. Anything? Will we have a session for that class assignment 2? Okay, so guys, class assignments 1 and 2. So I'm gonna show you guys something real quick. Okay, so let me see if I can do this to this. Let's see. Okay, what class am I in right now? Okay, so guys, this is for those of you all who are in the V01 class. Okay, so if you're in V01, let me see. Here we go. Okay, so guys, if y'all are in V01, so this is just my regular statistics class, right? And guys, I did it for both classes, okay? But if you click here on weekly activities, what I did is I went back and I labeled, oh, here's class assignment 1. And here's class assignment 2, right? And I'm going to show you guys, those of you who are in the V07, these are all my classes, guys. But those of you all who are in the V07, you'll be able to find them as well. Okay, so here's class assignment 1. And here's class assignment 2, okay? So you can see where those are, okay? Victoria, I'll get to your question right now in 1 second. So, but actually, let me answer real quickly. Yes, it'll tell you round to 3 decimal places, round to 2 decimal places, round to 4 decimal places. And guys, one thing I want y'all to know, after you guys submit your test, I always go back and I look at your test. Every single student, I go back and I look at your exams. And if I see that the only mistake that you made was rounding, I always give you credit, okay? I always go back and I give you credit for that problem. So if the answer was, round to 3 decimal places and you rounded to 2, I go back and I make sure that you get credit for that problem, right? But try to be careful as you're doing, okay? So if you do not turn in class assignment 1, definitely you can turn it in. It's due 1 week from the night, guys, next Thursday by 6:30 p.m. For class assignment 2, I sent out a video last week, but I'm going to resend it tonight. So I did a problem that was almost identical, very similar to the problem you guys have in class assignment number 2. So I'm going to resend that problem out tonight. I'll send it both on Pronto and Rhyme. And I kind of talked through the way I did this problem, and then I tell you what the difference is for how to do class assignment number 2, okay? And the video isn't too long, guys. It's like 7-8 minutes, something like that. But definitely, you can still turn in both of them in. If you never turn in class assignment 1, know that you can do it. Tomorrow morning, guys, I'm going to go through my messages to see, who's turned in what, so I can start updating my grades. The earlier you turn them in, you're welcome. The earlier you turn them in, guys, the better, right? So like, I know it's not due till next Thursday at 6:30, but if you get a chance to do it tomorrow or Monday or Tuesday, send it in as soon as you have it done, okay? This way, for like myself, because all my classes have class assignments 1 and 2, not just the stats courses, but like my Math 100, my college algebra, they do as well. And I'm doing the same thing. So I'm trying to get knock as much of the grading out as I can, right? So anyway, 14 questions, y'all, okay? It's just 14 questions. They come directly from the review. The only thing that changes are the values, right? But like right now, we did 29. If that question was on your test, that question would look exactly the same, except with some of the values being different. The story doesn't change, anything like that. The problem is exactly the same, okay? So guys, I know our tests are on Monday and Tuesday. Between now and Monday or Tuesday, if you guys have questions, message me on Pronto, message me on Remind. I will do my best to get back to you. I'm sure everybody knows Sunday is Mother's Day, so I'm probably going to be a little busy on Sunday, guys. But if I may try to check my messages Sunday evening. I can't guarantee that I will, but I'll definitely check them Monday. I just don't know if I'll get a chance to reply to you, those of you who are going to test Monday at 10 a.m. So if you have a question, you got to test at 10 a.m. I may not get back to you if you message me, Sunday afternoon or Sunday morning, something like that. But if you're gonna test Monday night or anytime on Tuesday, I'll probably get back to you, okay? And guys, so next week I'm testing every single day, 10 a.m., 6:30, 10 a.m., 6:30 for all my 4 classes. So if you message me during that time, I may not get back to you immediately because I'll be busy testing. But if you guys have questions on stuff, just let me know and I'll do my best to get back to you as soon as I can, all right? Do you guys have any other questions about anything else? I want to make sure that you guys feel okay about all this stuff. And I appreciate y'all showing up. I think I'm glad y'all were here. I hope that our answering some of these questions tonight made some sense and makes you feel a little bit better about, the final next week. And I hope everything went well, guys. I really tried to make sure that my videos were direct and to the point. And, like I said, nobody asked for this. I'm gonna stop recording. Nobody asked for this